Hi everyone, welcome back to From Python to Rust. In our DNA Toolkit series, we used Python strings, lists, and dictionaries extensively. These data structures are very useful and they make our life very easy in Python. Let's see what Rust has to offer. We're going to start by looking at strings. There are two types. One is called string slice and the other one is just a regular string, which is more or less the same as in the other languages. I'm going to link to an amazing video on strings in Rust, so please make sure you watch that if you are completely new to strings in Rust. In this video, we're going to focus on how we can use strings in Rust to replicate some of our DNA Toolkit code. In our first segment, we're going to take a look at strings, but before we do that, let's do some cleaning. As you remember from our last video, we created main files for both languages and we wrote all of our introduction code here. To avoid writing a lot of code in one file, we're going to create a file per video. We're going to take the code and wrap it into a function. Then we're going to include it into our main file and call those functions in our main file. So let's start by creating a file called intro.py and moving that code into that file, and the same for Rust. And for Rust, it's going to be the same, intro.rs, of course. So let's start from Python. Let's actually move to Python side here. Now we're going to go and cut this whole code out, and let's define a function and call it intro as well. And our code linter doesn't really like adjusting our code. Okay, so let's go back to main file. So from intro, import intro, of course. And let's create our main function and call that code in here. Let's see if this still works. Okay, our Python code works. Mind you, you should ignore these folders like PyCache, VS Code. These are kind of local for your own project. So when you're going to run, you're going to have these temporary files created for your projects too. So ignore them. So let's do the same for Rust. Here we're going to keep the main function. We're not going to recreate it. We're going to cut this code out. And here is where we're going to take a look at how to include files into other files in Rust. So let's do this. Let's create a fun. We're going to name all of the functions the same way in both languages. And let's paste it in, and we're going to see that Rust has nice formatting for us. The other thing we're going to do is we're going to cut the introduction code here, so we can run this code every time we run any functions. We should do the same for Python, by the way. Let's cut this out. Okay. And put it in here. So before we run any function, we're going to print out the language. So in Rust now, what we need to do is, instead of importing, we're going to include it. Okay? And because the file is a local file, meaning all the files are in the same folder, we don't need to specify a path the same way as in Python. So it's intro.rs. We have to specify the file extension too. So now let's try calling this function. If I can spell it correctly. Okay, we can see it works too. So that code is much cleaner now. We have our main files and we have our additional files here. Okay, so now we can maybe close these for now. And let's start looking at strings. First, we're going to do the same as for intro functions. We're going to create our files for strings. .py. Make sure you don't create a file, especially in Python, called string.py, because string is already a built-in library for Python, so they're going to conflict. So strings.py and strings.rs. Okay. And let's create our functions, of course. Let's actually try copying this and creating it the same way. And now let's paste it into Rust and let's move it to Rust side here. And of course it's not def, it's fn, and we have these curly braces and we don't need a pass. Okay, now we have empty functions, we can start putting some code into them. So let's first add some code to Python. Okay, so here is our very basic string in Python. Hey to all Doom, Duke Nukem fans here. So string Doom, we're going to print that string. We're going to plus equals, just append some stuff to it, which is number 3. and let's append exclamation mark as well. We can see here we're doing these double quotes and a single quote for a character. As you might know, Python doesn't really care. We can do this too. But as you will see, Rust cares, or any C-based language does care. You have to make sure that when you pass a character, it is a single quote. So maybe we're just going to do the same so Rust and Python matches. Let's close our sidebar for now. And let's try running this code. Of course, we need to go back to our main file and include that file. From string. See, that's what I said. It has string already, so we need to make sure we call it strings or something else. Import strings. Okay, and let's comment this code out because we don't want to see extra output. We just want to see the output for this particular function. Let's run it. And of course, this is the expected result, right? So if we go back here, we have do, we have space 3, and we have exclamation mark. Now let's look at the Rust code. It will be very similar. Okay, so here's the Rust version. We are going to use this type string. There is a type called string slice that looks a lot like Python, but it's more for a stack allocation. Heap allocation is dynamic. We can expand our string, we can change it as we run the program. So we're going to use this type of string. It gives us a lot of flexibility, as we will see, all these methods on it. And again, the video I'm going to link explains both types in depth. So you can see if you want to use the string slices or strings in your code, but we are going to use these strings. So this code is very similar. We just create our string, we make sure it's mutable, meaning we can change it, and we create string from do. If you are going to create something like that, so let's say str string, you can create a new string, okay? And as your code executes, you can modify these strings, but we're going to start with do as a base string in it, the same as we do right here. So as you can see, in Python, you can do just plus equals, and you can keep appending symbols or strings to an existing string. In Rust, you have to use methods that are built into the string, okay? So let's actually run this code now and see what it returns. Of course, we need to come back here and we need to include that strings rs file, okay? And let's comment this code out as well. We're going to call our strings, if I can spell it out. Okay, let's try running it. Okay, so let's go back to our strings file. We see two things. First thing is it does work and it produces exactly the same code as Python, okay? But the other thing is Rust says there is dead code. It says, oh, you have this intro function. Let's go back to our files. Okay, and you can see there's a warning here as well. Never used. It's a dead code. So Rust doesn't want you to have code in your files that is there but never used. It still has to be compiled, that takes space and things like that. So what you have to do is just add underscore in our case. And when you append this underscore to the function, it will just get rid of that warning. Let's go back to main, and of course you have to change the name of the function here too. And we're going to do the same for strings and all of our functions because we're going to be commenting them out and not using them. Okay, let's come back here and do this too. So now, even though we have a dead code, it's here, it's implemented, but it's not used. We're not going to see the warning message. We see just a clean output. Let's try running Python and Rust again, and we can see it's the same code. So yeah, you can see code side by side and it's almost identical. You just have to remember that instead of plus equals, we're using these methods. And I was talking about double and single quotes here too. Let's try changing this to double quotes. Okay. And saving it. We don't even have to run it. It already tells us that. Expected character found string. So strings and characters in C style language, which Rust kind of is very important and they're very different. So now let's take a look how we can add two existing strings. Here we have an existing string, but we're adding stuff that is not existent. It's just being added as a character or as a symbol. Let's implement the code that has already two strings, like that. So now we have two strings, Duke and Nukem. Some of you might know it's a classic first-person shooter game. And in Python, to add these two strings is as easy as p3 equals p1 plus p2. And we're using the f strings to print it out. Let's try running it. We have to go back to main file, of course. And here we go. Okay, it does work. Now let's see how we can do that in Rust, okay? Now, here we have very similar code. We are declaring two P1 and P2, two variables, and we are populating them with these two strings. And then we're doing exactly the same thing. We have P3, and we are adding P1 plus P2. So now we can see there is one problem. P1 is complaining that, oh, value borrowed after move. This is because when we did this part here, we gave an ownership of P1, which is a string that has Duke, to P3. Okay? It doesn't complain about P2 because we are using the ampersand here. We borrowed the memory location where Newcomb's string was saved, and that's why the P2 is not complaining. This is the way Rust strings work at the moment. So if you're going to be adding more strings here, for example, we have something like P5. They all have to be with the ampersand, and the first one does not have an ampersand. So how can we fix that in Rust? We can use a format method that will combine all of the variables we're going to pass to its strings into one string without affecting any ownership. So we're going to mark this as we'll generate an error, and let's use format method instead. So P3 is equals a new string from, and we're going to use that method format, and we are giving it P1 and P2. And now we can see that the error message is gone. Let's try running this, and we can see it generates the same code as Python. Let's go back to Python and run it again, just to make sure. Yes, it's exactly the same code. So yes, if you want to combine multiple strings or you want to run something in a loop and combine multiple strings into one, you can just use format method, store it in the mutable string. Here we don't have mutable because we are just creating it on the spot from. If you want to add more stuff to it along the line in your code, you have to make sure it's mutable, okay? So now let's take a look at one last thing. How can we access individual characters from a string? Maybe we want to have enumeration as well on top of that, meaning return a character and return an index of that character. And what is really important for us in the future for bioinformatics code is how can we grab a slice of the string? Okay, that will be used in our algorithms when we use for certain patterns. Let's say we have a DNA string that is 5 nucleotides long, and we're going to search a large string to see if it repeats in that string. So we need to be able to grab a slice. Let's go back to our Python code here. So in Python, it's trivial. We are using P3 as our test string, and we say for every character in P3, just print a character. Yes? So for enumeration, we have Python's built-in enumerate function, and it returns a tuple, meaning position and character. And we can print out the position and the character. And slicing, of course, is very easy in Python. We're just telling it, can you return P3, but only characters from 0 to 5, which is 0, 1, 2, 3, 4 is a space, and the fifth one is not included. That's easy. Let's try running it. Let's go back to main and execute it, and we can see. So the first thing is it did print out our characters, Duke, Newcomb, okay? And then we printed out the same string, but with the positions, 0, 1, 2, 3, 4. And if we look at the slice from 0 to 5, it returns Duke with a space here. So now let's take a look how we can replicate that in Rust. So in Rust, it's almost identical. We are using built-in methods in strings. That one returns a character, basically an iterator that we can iterate and grab a character in a string. And it doesn't really have an enumerate function. It has a specific function to return a character with an index, okay? We can actually point at them and we can see what they do if you have the plugin installed, okay? So this is easy. We just say ch character from P3 characters return, and it will return here, and we're printing it out. Same as the enumerate, it returns a tuple. So index, we should call this position, I guess, to match. Just like that. And it will return an index and a character. And the slices are done very similar way. We just say P3, but we're using an ampersand again. We're borrowing the memory location. We're saying, can we have that memory location? Okay, it's a string. We know that it's a string. And can we have a slice of it? And let's try running Rust code. Now we can see that Rust version does exactly the same thing. It returns character by character and then returns character by character with an index. And of course, Duke has the 5 characters. I can see there's a difference. There's 2 spaces, I think. Let's try Python version. Yes, and there is 1 space. Let's investigate that. That probably is this format method we used. Yes, we have implemented the space here. and we have a space here. So it has double space. Let's remove that space, and it's going to use just this space. Let's try running it to make sure they're all completely the same. All right, so that's strings in Rust, and this is more than enough for us to try and port some of our DNA Toolkit Bioinformatics code. And let's do that now. So now before we start porting two functions from DNA Toolkit, one will be generate random sequence and the second one is DNA to RNA transcription. As you remember, generating random sequence requires random module. If Python has random module built in as a standard library, Rust doesn't, and we're going to have to get a package, a module. They're also called crates in Rust. So we're going to say, okay, we have this project in Rust. We want to use some random number generator. Let's go to this package repository. If you know Python has its own, it's called pip, right? It's a package repository where we can download something like NumPy, Pandas, because it is not included in standard libraries. We have to do the same for Rust for most of the packages, okay? But don't worry, it's very, very easy. So first thing we're going to take a look at will be this cargo toml file. We're going to close Python for now. So cargo.toml file has your project configuration. We're not going to change anything. We're just going to take a look at dependencies. This can get very complicated if you have something very custom in your project. So dependencies is empty, okay? So how can we search for a package in Rust? There is a system called Cargo. You probably are familiar with that. So Cargo allows us to search for available packages. You can now open a separate terminal or you can use a built-in terminal, which I prefer to do. I'm going to go Control tilde, and now we are in the terminal. Just to make sure that we are in the Rust project folder, you can type cargo search, and let's just type random. Okay, it did find a lot of crates. This is what I meant by packages are called, not packages or modules, are called crates, okay? So we see that rand is random number generator. We are going to use this one because it is a main crate for Rust. How can we add that to our project? We can do this thing. We can just copy literally the string and paste it in here. What I would do instead of 073, I would just leave 07. I do that to make sure that when the update is available and we run our project, it will look it up and say, oh, there is a new update for random module. Let me pull down the latest version. So if 074, 075, 6, 7 come out, it will be pulled down automatically for us. Okay, so we've searched for random module and we have added that line into our dependencies on line 10. We should save that now. You don't have to do anything else. When we're going to run our code that actually uses and includes that random module, Rust or Cargo system will automatically pull down the latest version of that dependency and build it for us and run our code with it. Now let's close our toml file. We don't need that anymore. And now let's create two more files. Because these two files are going to contain DNA Toolkit ported code from Python, we're going to call them DNA Toolkit. So for Python, we're going to go here. .py. And for Rust, DNA.rs. So let's look at the Python version first, as we always do, and let's move that to Rust and close all the other pieces of code here we don't need. Now we just have main and DNA Toolkit. So let's look at the Python version first. That's an easy one. As you remember, Python has this random module. We're not importing the whole module, we're just using a method called choice, okay? So it chooses a random element from a non-empty sequence, and the sequence in this case is a list. So we're passing a length here, and we are creating this list of nucleotides, ACGT, we're creating an empty string, and we're just looping through that length. Let's say we pass, can you generate 10 character long sequence, and it's going to loop 10 times. And we're just using this choice method that will pick random character from this list and append it to our string. And then we just return the string. Very, very simple. Before we go ahead, let's test that. Of course, we need to import it. And let's call this function now, and we should not forget to comment this out. and we need to pass a parameter. That's an interesting part. Now we're going to be looking at how we can pass parameters and return strings in Rust. And of course, we need to print this out. Because it is returning a string, we need to print it out. Here we go. Let's run a couple of times to make sure it generates a random string for us. That's great. That's easy. So now, how can we do this in Rust? Let's go back to our DNA toolkit so we can compare the code. The code will look very, very similar. Okay? Now, here is a Rust version. We're including in Python here random module and the choices method. And here in the Rust version, we're saying rand, and that's the crate that we added to our dependencies. And we're saying, can you include random number generator? Okay, RNG. We're calling the function the same way. Of course, the underscore to make sure there's no warning. And this is how we pass parameters to functions. We're passing the same kind of name. The variable has the same name. But here we are explicitly telling it we want to pass integer, okay? If we're not going to do that, it will be confused, like what are you trying to pass, a string or integer, things like that. So we have to make sure we specify. And this is how you return a variable in Rust. So in this case, we are returning a string. So if you're coming from, let's say, C, C++, Java, you probably are used to having the return type in front of a function, something like that. So if we want to return a float, right, we do this, do map, right? Let's say we have this function in Java, C, C++, C#. We have the return type here. In Rust, the return type is done like that. We have this arrow symbol, and then we're telling it what we want to return. And of course, you can return multiple things if you combine them in a tuple. So here on the line 4, we are using a vector instead of a list, because of course Rust doesn't have list. And we are creating a new empty string, just like here. We are using a for loop just for demonstration purposes. Of course, you can use a list comprehension in Python and have this just one line, and maybe even just return the whole list comprehension. But we're going to use for loops just to see what is happening. We're using these underscores because we're not using this variable here. We're just iterating, and we're not going to use that symbol. So we're saying for underscore in length, but instead of range and length, we're saying the range from 0 to length. And the length, of course, is what we passed to this function. Here we have a string that we created here, newly created string, and we're using a push method that string has, and we keep pushing random characters from nucleotide. So here is our nucleotide vector, and it has 4 characters in it. Characters, not strings. And we are using push instead of push string. So here we are using this long code, but it's not very complicated. That's the random crate. So what it does, you can see here, it says retrieve the lazy initialized thread local random number. So it just returns a random number generator, and then we are calling this method genRange. So in Python, it's a bit smarter. It just knows that this is a list and it has 4 characters, and it will just pick from these 4 characters. But here we're not really picking characters, we're not choosing characters. We are generating a number from 0 to 4 because nucleotide vector length is of course 4. So that will return a number from 0 to 4, not including 4, of course. 0, 1, 2, 3. Okay, so there is a kind of first big difference. Here the choice method accepts the list and picks whatever is in the list. And here we are giving a push method that will push a character onto a string, our nucleotide vector, and this function here, or set of functions and methods, will just pick a number from 0 to 4 and return whatever is in that index. Okay? And of course, we're just doing a typical return. Let's try running this. We have to go back here and of course include that too. Okay, so we have included our DNA toolkit. Let's comment this out too and call our gen function. And we're gonna pass the same value 10, and we want to print this out, okay? Because it returns a string. So here's our function, returns a string. Okay, now we are ready to test the function. But before we run this code, I want you to see how the random module is going to be found and built and added to our project. Because we have added this queue in our first video, this means quiet, run cargo quiet, meaning it will just give us the output. This will hide the whole process of crate building and adding it to our project. So let's remove this queue for now, just so we can see that the cargo toml rand module is going to be picked up. So I'm going to go F1, settings, and I'm just going to do this quick modification just for the demonstration purposes, so you know what is happening. Here's Rust. Instead of modifying the string, let's copy the string, comment this one out, and just modify this here. Okay, we're going to remove Q, and we're going to remove Q here too. Okay. Let's save that. We're going to keep this opened, and let's make this a bit bigger. So now we're going to run this code, and I want you to watch the output window and this part here, RLS, Rust Language Support Module. Okay, let's try running this. Okay, now we can see it's compiling. And here it is. You might see a little bit different output here because this module was already downloaded on my machine for my other project. So you might see an additional line here, just kind of a loading screen here, downloading the crate, and then it will go into compiling and building this crate. Okay. So here it is. We didn't really have to do anything by hand. We just added a dependency. We used it in our code, and Rust was smart enough, the cargo system was smart enough to pick it up and build it for us. Let's try running this again. We shouldn't see this output anymore because it's already built for us. And here it is. Okay. I'm going to go back and comment this one out. Now, as you can see, we are running a debug version, an optimized debug version. If we're going to try running this as a release, it will have to kind of recompile that rand module for a release. Okay, let's try doing that. I'm going to open the terminal here and I'm going to run cargo build ---- release. And we can see that building process happening. This is for the release. It wasn't really built, so it will not happen the next time we run the release version. Now it says optimize. We can just try running it like that. Run release. And here we go, optimized release version. Let's try building it again and see what's going to happen. It's not going to build it because it's already built and ready to use. So this is how you can include Rust modules, or they're called crates again. And cargo system is so smart, it will just build everything for you. Okay, so we can see that both versions work just fine. If Python was a bit easier, random module is part of the standard library in Python, then in Rust we just had to search for the random module and just include it into a file and build our project. That's it. So now we're going to import one more function, and it is going to be a transcription function. So here is our transcription function. We are passing a DNA, which is a string in this case, and we're just replacing T with U. For those who are watching this for just Python and Rust, and not bioinformatics, on very basic level, what transcription is, it's a biological process of turning DNA strings into RNA to be transferred into proteins. And this is done by just changing one nucleotide from T to U, thymine to uracil. Okay, let's see how this works. We can come back here, and of course we can include that from here too. So transcription. And let's create a variable called DNA. Make it equals to whatever this function returns, which is a random sequence. Okay, and then we're going to print DNA. And below that, we're going to print a DNA string that we generated, but a transcribed version. Transcription. Okay, so let's do a transcription. It's a very good way to visualize how our code works. So we can see that T was swapped with U. Okay, let's run it a couple more times. TU, TU, nothing else was changed. So this is a very simple function, okay? And it looks identical in Rust. So here is our Rust version. Here we were passing a length, an integer, and here we're passing DNA and a string, okay? And we are returning a string the same way we did here. And luckily enough, strings have replace method in Rust the same way they have in Python. So we are very lucky in this case. And let's try this code now. Now let's do the same thing. Let's create a variable called DNA, and it's going to be equals to this string. Let's do this, because it is much easier to read the code. When you look at it, you know that this variable will store a string instead of some whatever the compiler will interpret for us. Okay, so we're going to use from, and of course we're going to return that string. And now it says, okay, you have DNA, it is not used anywhere. So let's use that variable right here. Okay, and let's print out the transcribed version below. So we need to change this to transcribed, and transcribed accepts a string. And the pop-up shows us what it accepts, a string, but as a reference here. So we need to make sure that it's not just DNA, it's the memory location of DNA. So we are borrowing its memory location to do some operations. We're not giving it an ownership, okay? So let's take a look at the code again. So we are creating DNA string here, string, and let's change that to 20 just for test's sake here. 10, 20, okay? And let's try running this. Here we go. So the same code in Rust, and we can see that transcription works. TU, TU, TU. Okay, let's run Python again. Python, Rust. Okay, so this is it for this video. Let's take a quick look at the file structure we have so far. Here it is. So we have a source for Rust, and we have 3 new files: intro, toolkit, strings, and we're going to create these files as we go along, and the same structure and the same function names in both languages. Okay, so this is it for today. Thanks a lot for watching and listening. In the description below, I'm going to leave a couple of links. One to very good Rust strings video. The other one is additional Rust strings methods you can use, and also an article version of this video. And as always, if you liked the video, please make sure to thumbs up and share that video. And until next time, Rebel Coder signing out.